Okay, welcome everyone to the first seminar of the Computational Humanities Research Group at King's in 2025. I'm very excited to have Thibault Cle here. He's a computational humanities and natural language processing researcher specializing in classical philology. He works at INRIA within the Almanac project team, focusing on developing resources and models for the analysis and structuring of textual data, particularly for ancient and historical languages. He's involved in projects that support open access and reproducibility for NLP and computational humanities, such as the COLAF initiative, which focuses on the languages of France. And he also used to be here at King's as research software engineer in the Center for E-Research around 2013, when it just merged with Department of Digital Humanities. So a very warm welcome back. And we're looking forward to hearing your talk on building a cross-lingual dataset for medieval manuscript text recognition, challenges and outcomes of the CATMuS.
Thank you. So while I charge the slide, just want to say hello to Elena, who I haven't seen in a long time and I'm seeing online. So I hope you're okay.
Nice to see you.
I can't hear you because to avoid back, but
okay.
So is the sharing working for you, but not for the slides? So
just also, is the audio okay for everyone? Can you say you can?
Good for me.
Yes. Okay. Perfect.
Okay. So I'm loading the slides also on the projector. And as soon as it's online, so everyone sees the slides, everyone can hear me well, and soon even people on site will be able to profit from the slides.
Yeah, exactly.
Mirror display, please. Okay. And I'm going to cut anything that will leads to notification. Okay, so thank you again, Barbara, for inviting me. It's of course, as you mentioned, a pleasure because King's was my first job in DH, so it definitely is a special place for me. And today I will talk about building a cross-lingual dataset from medieval manuscript I should have said for medieval text manuscript recognition, and specifically the challenges and outcomes of CATMuS, which is the initiative I'm going to talk about. I didn't know the level of the audience, whether it was in medieval studies or in computer vision or computational humanities. So I will maybe be explaining things that you know. I'm sorry if that's the case, but let's start. So what is HTR, or what rather, when people talk about HTR or OCR, what they are talking about most of the time is HTR workflow. And generally it involves getting a picture, potentially post-processing this picture to enhance contrast, for example, and then doing layout analysis, so finding regions and finding lines. Then finally doing text prediction, which is the exact step which is called HTR normally, and then doing some manual correction, and then retrieve the data and work in your project. So I just wanted to go back to this very small definition of what is HTR, and HTR is these parts and not the whole thing. And in HTR, or I see the wording ATR getting more and more traction for automatic text recognition to merge kind of HTR and OCR together. In the context of ATR, there are multiple things that are also encompassed behind the word AI, which I always want to talk a little about. First of all, there is like the fundamental research in terms of computer vision, or even mathematics, which is the model architecture. So that's one piece of the jigsaw puzzle. And then you have the software, so people that actually go executable code that will help you run this mathematical architecture. And then you have the models. So basically what was learned by what was taught and learned by the software. And finally, you have the training data. So this piece of thing where people created annotation tailored to their needs. But it also includes infrastructure or computer hardware, whether you're using eScriptorium or Transcribus, for example. You are definitely using an infrastructure somewhere where people have to pay for electricity and storage, for example. And of course, the research around HDR, which is something on top of everything else. So let's go back a little to HDR. Nowadays, there are two main HDR paradigms. HDR engine based on baseline through segmentation. So basically, the model defines where the baseline is, and then the software uncurves baselines to get something that is more like straight and computes a polygon around the line. That's, for example, what happened in eScriptorium and within Kraken. This allows for handling highly curved and round lines. And as such, it allows for more exotic situation. It's also a little bit more computing expensive in terms of computing. And then you have HDR engines such as Pylaya, which was or might still be used in Transcribus, which are based on bounding box or a little more complex polygons. So basically, you have a rectangle which is drawn around the text, and whether it's curved or not straight, it's still gonna take the full thing. It's not gonna be as complex as the baseline in drawing a polygon, so you're gonna end up with a little more noise, but it's also much faster. The only issue is if you have very round lines, it's practically impossible to deal with them. And then you have not in the HDR for now, but in the OCR world, you have a revolution where some models are actually doing everything at the same time. So I say that HDR is segmentation and then recognition of the text, but you have models such as NuGet from Meta, where from the page it's generating Markdown, and it's not multi-steps, it's image to Markdown directly. And this kind of research is still like quite limited, I would say, but it's getting traction since this big publication of NuGet. So now that I have set up the landscape, and specifically to talk about CATMuS, I wanted to talk about the notion of generic models. When people use the word generic models, so models for HDR, recognizing text, they are thinking about models that are going to be able to treat a wide variety of documents in a specified space. So generic can be ultra generic. I have a model that can deal with any scribe from any century, and it works very well, or generic within a smaller space. For example, any Latin manuscripts from the 10th to the 12th century. I would still call that generic, opposed to specialized, where the model is specific to a specific manuscript. Generic models aim at balancing overall accuracy on all documents rather than learning more about a single one. So you're gonna have definitely a balance between having a model that performs rather well on everything, instead of having a model that performs extremely well on a single manuscript. And specific models are generally either created from scratch, trained from data of a specific manuscript or subset of manuscripts, or derived from a generic model. We take the weight of the generic model and further teaches it to learn more about a new subset of documents. So this model will be very good on this specific manuscript, but it will be obviously worst on other manuscripts. This generic to specific model process is called fine-tuning, and it allows for faster training time. So basically, as soon as you have a very good generic model, training specific and this means that the money and the energy, and as a consequence, the money and the carbon that you spent on training the generic model is gained every time, is recouping. Can I say that? Yeah. So it's leads to benefits on training some model. If everyone were training their own model from scratch, it would be much costly. But training from this generic model is less expensive in the end. And I like to take the example, we have a tendency to humanize AI model. Like fine-tuning a model is like, instead of training the model from scratch, is like, instead of taking a model from kindergarten to back, and I don't remember the name in, so to university, let's say, from kindergarten to university on specific manuscripts, you take a model that was trained from kindergarten to the beginning of university and learn everything that they could learn, like we do. And then it's going to be specialized in a specific field at university. And that's basically the same process of fine-tuning. And it means that it's going to retain when it's getting fine-tuned. When you arrive at the university and when you end your university degree, obviously you still remember some stuff of primary school and secondary school. It's the same thing with the model, but you don't remember everything. So there is some knowledge retained, which explains why the model will perform better than a model trained from scratch. Okay. Now, if you were able to follow that, let's talk about some issues with HTR in medieval time. So the first biggest issue in HTR for medieval manuscripts is spacing. We take space for granted in modern world, but if you look at manuscripts, you have three kind of situation. You have the continuous scripta continua, so no space. You have something that is a little aerated, but honestly not perfect, because the notion of space is not the same as the modern one. And then you have the separated, but it's still very weird. If you look at est mihi here, the spacing is clearly smaller than between mihi and in salutem. And actually in salutem should probably have a space in between. So the spacing is definitely not the one that we would have in a printed edition. Then you have what we call allographs. The most common allograph that we know nowadays is long S and S, because we still see it in printed book from the 19th century. But in medieval times, you have much more variations. So here you have an open A, and I don't remember the name of this one. I think it's a D rotunda and a D, and a long S and a S. Oops, sorry. And then you have abbreviation. So N superscript A could be nulla, natura, nota, or nomina, depending on the context. And so those are already some issues that you won't have in print, except for the S versus long S. And then, on top of that, you had graphical variation. Middle Age is such a long time, right? Depending who you ask, let's take the largest still acceptable time span, so 5th century to 16th century, still quite large enough that I should not make anyone angry. And then you have the Caroline. Here you don't have, but you have the Initial, you have the Cursiva, the Pre-Gotica, and those are the big families, because after you have, for example, for the Textualis, you have the Textualis from the Saxon world, you have the Textualis from the Mediterranean world, and it changed a lot. And then you have the more cursive one, the less cursive one, and you end up with a big mess of diversity. So it's not because you have one category that every scribe is going to write a perfect one, like when you print in time Romans, you have always time Romans. No, sorry. Yeah, it's time New Roman.
Times New Roman,
Yeah. It's always be time New Romans, but textualis will not always be a perfect textualis. And then, because of the issues that we have mentioned, you have the act of transcribing. And transcribing is a specific thing where you have to actually make choices. It's not simply, it's not as simple as writing what you see. You will have to interpret. Sometimes you will have to translate, and you will have to somehow describe. And transcribing is betraying, and it also can happen in print. If you take, for example, if you ask 100 person to transcribe a printed page where you have footnotes with superscript ones, I can assure you that you will have very different transcription of this superscript one, even though it's in print. You will have people that might use like a superscript option of Transcribus or Scriptorium. You will have people that will go to the Unicode to find the superscript one. You will have people that will use kind of LaTeX transcription with, I don't remember which character it is for LaTeX, but whatever. Maybe some people will just put a 1 and don't care about the fact that it's superscript. Well, for medieval manuscript, for all the different reasons that we have seen, you're going to have the same kind of issues. And I'm going to exemplify a little what happens, I'm going to show you some of the choices that are available. So, for example, here, might be less readable for you than for people online. You can see Carl, C-A-R-L, and the L is stricken through and a dot. And depending on who you ask to transcribe, you will have Charles, as if it were in a printed book. Carls, so no homogenization, even though we say Charles in French, but still normalized. Then some people will have the abbreviation non-resolved, so Carl. And then you will have something that is closer to the manuscript with what I would say is no normalization at all, C-A-R-L stricken through dot. But we do not have issues only with abbreviation or normalization. Even punctuation can be an issue. This dot, for example, in normalized edition would be a comma. In a transcription of the manuscript in a semantic way would be a dot. But if you want to be faithful to the manuscript, the dot is in the middle of the baseline, above the baseline. So you should be transcribing it with a dot in the middle of the baseline. You have allographs that, like I said, so graphical variation of letters, round S or long S. Spacing issues. So here you have mater. Should you write ma space there? So my earth, or should not be earth here. It should be land, probably. My land with a space. My land without a space. Or should we respect the kind of amount of space you find between each letter? So actually there is as much of space between the M and the A as the A and the T. So should it be M, A, ter? And all those questions lead to the question, then if you want to teach HDR, an HDR engine, sorry, or to transcribe this, you should be as consistent as you can over time so that the model doesn't behave differently in different situations. So what you need is to build transcription guidelines. And there are really three kind of options. And every time you go into setting up transcription guidelines, you end up with these kind of discussions. That's obviously AI generated. I think I asked it, try to represent scholars debating, writing transcription guidelines of handwritten text recognition. in a manga style because everything else was very weird. And I really like this generation because that's exactly what it happened sometimes, not always. So the first option is to do an allograph transcription. So basically one handwritten sign is one digital sign. One digital sign is basically a character in the Unicode. So the unit is the allograph, not the semantic character. And by teaching an HTR model to do that, what you are doing is you are reducing the amount of things that the model needs to know about the language. Because it's not about like S versus long S, it's about, okay, there is the S and there is the long S. And you don't need to try to guess what the characteristic of the language like, what is the most probable character that is coming next, because what you should be concentrating about is the shape of the character. The issue is you end up with a large number of characters to learn, and you end up with the risk of having very rare classes with no recognition, the risk of missing Unicode symbols for specific characters, and something that is not often talked about is that the more classes you have, the higher the error rate. And when I say the higher the error rate, I'm not specifically talking about the machine, but I'm also talking about the transcribers, because people will see characters differently. And honestly, sometimes the difference between long S and round S is easy, but like round A and normal A might be a little more fuzzy. The second option is what I will call the edition style transcription. So you don't focus anymore about the manuscript as an object, but rather at the content that the manuscript is holding. And so what you will try to do is transcribe as if you were editing the text. And so the unit doesn't remain the character anymore, or sorry, the shape of the character, so the allograph, but it's a word. So you resolve abbreviation, you modernize the punctuation according to the practices of your field. And the good thing, it's producing more easily exploitable data. And it's definitely cheaper in the short term, because what you can do is, I've got a lot of printed edition, I've got a lot of manuscripts, and I can try to align them automatically. And that's things that some people have done a lot. But the issue is, and I will talk about that a little later, the machine sees only one line at a time currently. There is no model that is treating multiple lines at a time, which means that the context that they have to do the modernization is only the line. And the models can have a language model in them, but in the end, if you still have only like 5 words to resolve some abbreviation, it's going to be a hell of it's going to be very painful for even for a human sometimes to resolve the abbreviation in this sentence. Not in this sentence, actually, in this set of words. And depending on the language and the model that you're going to train might be dependent on the language, on the kind of document, and on the genre. If I train a model on literature with abbreviations that are specific to hagiography, for example, it will definitely not work on medical manuscripts because the abbreviations do not resolve the same way. And then you have the third option, which is graphematic transcription, where one handwritten sign is one digital sign, but you do not take into account the variation of shapes. So it's not the allographs, it's a character. You preserve abbreviation, and you take a compromise between simplifying the machine learning task and the usability of the output of the machine learning task. So basically, yes, you're going to have abbreviation, but you're going to also get a model that is going to be much better at recognizing things, whatever the language is, as long as it's the same script, obviously, and whatever the genre is, more importantly. It's going to be more independent from linguistic variation, but it will require post-processing. And so just as an example, there is a famous book from Capelli, The Element of Abbreviation. where you have basically a dictionary of abbreviations for Latin. I think there are other languages than Latin, but, and you have variation of some abbreviation here. So the straight line that stands for M or N, the con shaped letter, which is for con, com, can. The same letter but superscript, which is for us, os, is, s, and then other kind of shape for other situations. So basically, all of the graph transcription, you will have one character for each sign. But what you will do in a arithmetic transcription is you will have one character for each of those lines. So maybe like macron for the first line, con-shaped letter for the second one, and I don't know, 7 for this line. Or a good Unicode character, if it's possible. From those three kind of transcription, only 2 are compatible with each other. And basically, 1 can be simplified into 3, because you can actually translate very complex character to their simplified character. But 3 cannot be translated back to 1, because you don't have the details if you don't look at the manuscript. Sorry. And obviously, 2 has lost so many details that it's also not possible to go back to from 2 to 3 or to 1. So let's look at the perspective of, and the end user. So it's an oversimplification. I hope that no historian, no medieval literary researcher, no linguist, or no polygraph will take bad what I have simplified here. But if you look at the 4 main bodies of researchers around HTR, or around manuscripts rather, you would have this kind of graph where this axis tends to represent the preference to the closeness between the transcription and the text in the manuscript. So basically, it's the job of paleographs to care about the shape of letters. So they are going to be at the top of this axis. And most historians will prefer normalized text, and they don't really care about the abbreviation or the shape of the letter in the text. The same way, for historians, content is more important than language. But for example, for linguists, language is more important than content. And so what I mean by that is not that historians don't care about language or linguists don't care about content, is that historians are looking for sources, and they are looking for the information that are in the text, where linguists are looking for the information within the words in the text. And if you add in this world the computational perspective, you will have computer vision that is close to the paleographs, NLP that is close to linguists, but which most of the time works with normalized text. And then you will have HTR probably a bit in the middle here. So then you have those 3 sets of different guidelines. And while CATMuS made a choice, and I'm going to spoil it right now, we made the choice of the graph thematic approach, I'm going to talk about the editorial approach, because there are 3 papers that went this way and that gave feedbacks about it. So just to go back to what a model is just as clever as its data, right? I think it's something that is quite important to remember. And so a model is produced on data, it learns what it sees. A Kraken model sees line by line. It's the only context it has. A Kraken model, but most models will be like that, does learn some language features by accident when being trained. And the more a dataset is multilingual or include linguistic differences, lexical, spelling, syntax to a certain degree, the more it resists guessing based on linguistic features. So if you learn the same text, for example, charters, a charter will most probably always look the same way in the beginning. Someone sold to someone else, or sorry, cartulary. Someone sold to someone else, this kind of thing for this kind of reasons. There was a reason why NER in Latin was very, very efficient. Named entity recognition was very, very efficient for historical document, but not very efficient for literary manuscripts. It's because it's always the same syntax. It's very fixed. It's a formula basically. For because any AI model will try to cheat to some extent to find the shortcut to be the most efficient. What will happen is if you have always the same text, honestly, the model is not going to look at the picture anymore, and it's just going to guess based on what he has seen before. It's going to resort to a more language-based model. So as a consequence, a Quarkian model trained on one language only will always perform poorly on another language. Or, to be precise, it will perform more poorly than if it had been trained on the second one. Models are lazy, they take the easy path. You can teach a model to normalize text, but then what am I teaching and asking from the model? Am I giving the model as much knowledge as the editor had when they read the text and edited the text? When you edit a text, you know about the period, you know about the language, you know much more than what the model has seen, which basically is maybe 8,000, maybe 100,000 lines. As a human, you probably have read much more than that. So if even with all those warnings, I do train a model to create editorial level transcription, what do I risk? 3 papers. I will start with this one, which is the oldest one. Sergio Torres Aguilar and Vincent Jolivet. And written text recognition for documentary medieval manuscripts. So this is the kind of manuscript that you can see on the right. And I will take 2 quotes and then I will discuss them. So Aguilar and Jolivet go on to describing the results and do some qualitative analysis of the issues. Upon closer examination, this error often coincides with misrecognition of typical phenomena in medieval handwriting. This includes indistinctness in characters composed of successive minims, such as N, M, Y, U, misrecognized ligatures, such as ST and CT, undeveloped or incompletely developed abbreviation by suspensions, which are easy to fit, like nobis and francorum, by contraction, which are harder to fit, magister and dominus. Abbreviation with expansion depends on the declensions. Par, which can be resolved as Paris, Parisiensis, or Parisiense, depending on the context. And I give an example, but we're not going to go into that. So basically, the first paper says, and they used a simple Kraken model. The model works. It has good character error rate performance. But if you look at the results, you will have, I'm going to go back to the error, some errors that can be quite problematic. There is a very big difference between Paris, the city, and Parisiensis, the people of Paris, if I'm not mistaken. If magister is not well transcribed, then what is it transcribed into? Because they are saying it's not able to do it, but they are not saying what it is replaced with. Then you have a second paper, which is, so it's a preprint, so maybe there will be more modification, and written text recognition for historical documents using visual language model and GANs. So I'm not going to go on to the GANs part, but I'm going to focus on the visual language model. What they did is use TR-OCR, and they plugged in, he plugged in a BERT model, I think. I don't remember exactly, trained on Latin for the language model, and it's the same vision model as TR-OCR. I'm not going to read everything. I'm just going to focus on the quote that is interesting to me. So they are, again, that's their introduction here, not the analysis. Because they are using an explicit language model, they think that it is particularly crucial for addressing challenges such as complex layouts, ancient or noisy writing, or out-of-domain issues, where a purely graphical interpretation may fall short in providing an accurate transcriptions. So what they're thinking is that the language model is going to help on out-of-domain issues. But when they look at the errors, most errors from transformer model are linked to misprediction at the word or subword level, paradoxically increasing the CR more than the WER. This strategy is highly effective as evidenced by the significant difference in WER between transformer and CR. So basically here what they are saying is the WER, so word error rate, stays the same because the errors that are introduced are always within the same words, and so the word is not being correctly predicted, but the CR gets worse because it's the abbreviation that is the issue, basically. And then we're going to look at the, that's big enough for you, the kind of errors that we have. So the way it's presented is, the first thing is the manuscript, obviously. The first typed line is the transcription. The second and the third is their model, or rather a variation of their model, depending on the line. And then the last one is a Kraken line. It's always trained to resolve abbreviation directly, right? And what we can see here is that for the first example, it's taken from their paper, Orion de Flassigny a vendu à Henri, comte de Lusselbourg, la Fier et l'Ariafé que Messire Gilles dirait. You can see first that Henrion becomes Hugues. That the second Henri is actually just not de-abbreviated, just H. And then Lusselbourg becomes Luxembourg. Maybe the same thing. I don't know enough about this variation of this time, so maybe the same place, but it's heavily normalized. We can at least agree on that. But depending on the models that they used, and it's the same architecture, the second one just becomes Lus, just forgetting about the abbreviation. And obviously the Kraken model, which doesn't have anything to do with language, that doesn't have a very explicit language model, is worst at resolving the abbreviations. I'm going to look at the second line, and then I will come back to the same. So here it's two lines that are that are following each other. Sorry. In caps qui in locum defuncti parentis qui ex eodem natis sunt success. Here, the issue that you will see is paren is taken as an abbreviation because it's at the end of the line and it doesn't accept to have a word that is hyphenated, and you end up with patri or petri. Actually, you can see also that the model Kraken is a little better here because, again, the model is less explicit. And two other examples. Omnium peccatorum quia ex quo diabolus, quando esset infusum stultus esset. Diabolus become diaconus with their model, or dialus, depending on the situation. Infusum becomes infuturum, or infusum separated. Quando becomes que in the second version of the model. Omnium becomes omni. Quia becomes quod. So abbreviation resolution issues all over the place. And the fourth version, omni populo et cetera, quod figuratum, which becomes sigillatum, which clearly is OCR error transferred into normalization issue. I can see why figuratum could look like sigillatum. Est ester Judeis nova lux oirere. And then that is something that was reported to me. Apparently, in the presentation they did, so it's hearsay, but I wouldn't be surprised given the example that we have. There was a T dot or something like that that we expanded to 2 instead of trev in charter, because the data was not in the basically probably trev was not in the training data. I have two, I have still 15 minutes, right?
Yeah.
Okay. There are multiple issues here. The first issue, obviously, is it's not perfect. Well, a model that will transcribe with abbreviation will not be perfect either. The biggest issue here is that obviously those models are made for one thing, which is to be tailored for this part of the research field. Historians and medieval literary studies, in a way that I have 10,000 manuscripts, or maybe less. I have 100 manuscripts of charters. I'm going to transcribe them automatically, and you can do a search in this corpus, and you will find the data that you're interested in. In a context where people are expected not to go back to the manuscript. And because you only see Hugues de Flassigny a vendu à H. Comte de Luxembourg, Lafier et Larié-Fier que Monseigneur Gilles Diret, you don't know that H was abbreviated here. The only thing that you see is Hugues. Whether it was abbreviated or not, you will never know about it if you don't go back to the manuscript. And an HTR model is not the same as an editor. An editor, you should trust him You should trust them because normally it should go under peer review and the person has been trained and errors are possible, but ultimately you should trust them. The HTR model should not have the same level of trust as the editors that produce the transcription that were used for training such model. And the fact that you have those mistakes, where sometimes it could be OCR mistakes, but sometimes it could be abbreviation resolution mistakes, or sometimes I would call that hallucination rather than abbreviation resolution mistakes. You don't know the truth behind what led to this transcription. And you have two choices, always having the manuscript side to side, which honestly reduce the impact of having HTR, or trusting it. And there is this last paper. So we're gonna leave medieval times. The issue is very particular to medieval. I'm just gonna do an aparté in French. Digression, yeah, saying that maybe a parenthesis. This is very particular to medieval time for Latin scripts. Modern and contemporary scripts are way less abbreviated, and the abbreviation are much simpler to fit than for medieval times. Yet there is this paper which is interesting, Normalized versus Diplomatic Annotation, a case study of automatic information extraction from unwritten Uruguayan birth certificates. So this is the kind of document they worked with. So it's a form. You have a lot of information, name, city of birth, etc., etc. And they have two kinds of transcription for each document, normalized and diplomatic. The normalized is what you would see in a database, and the diplomatic is what they saw in the document. And so basically, if you have enrollee full name, Noble, no idea how to pronounce that in Spanish, Noble Alonso Rocho, probably. If it was written in full caps, then you find it in full caps. There is one weird thing from the point of view of medievalist. Here, the normalized transcription introduces abbreviations. So Enrique becomes E, and Marimelda becomes M, which generally is the other way around. You resolve the abbreviation, normalize, and you don't reduce them. But that's the way their data is. But it's still very interesting because we're going to see something. What they say is the normalized model, so they train two models. The normalized model performs much better on dates, jurisdiction, department, and year of enrollment. because basically it's a fixed vocabulary, so obviously normalized would perform better. On names, which I would argue is probably a bit trickier to correct, the diplomatic model worked much better, like 3 times better here, nearly 4 times depending on the number you look at, 5 times better for CER, so definitely good numbers. And they look at the error, and there is a very, very, very funny thing, which is not everyone has middle names in Uruguay. And so the diplomatic models sometimes just say, not possible. Let's add a middle name like E dot, because I have always seen middle names in my data set, so they should have middle name. And this is the issue you end up with normalization, is basically the machine has seen so many patterns, it's going to continue following this pattern if you're going further than what it sees on the data. So in case where no middle name was handwritten in the document, the model just invented one, presumably to agree with the format of the data it was trained on. And to me, specifically in what it was birth records, birth certificates, I would say that inventing middle names to people in birth certificates is definitely a no-go. But, you know. So, to go back to medieval times, there are actually very few combination of fields, so history, literature, philology, etc. Countries, France, Italy, Spain, Germany, or even subcategories, Anglo-Normand specialists versus Picard specialists. So Picard is northern France, Anglo-Normand is western France, and obviously England. That will produce the same transcription depending on the tradition of their field. An example is et in Anglo-Normand, I think, should be resolved just as an E. Whether in Picard, it will always be resolved as ET, because it's specific to the dialect. Any error is lost to the HGR. The decision to resolve is not visible in this model. The only reason this error were caught is because paper's authors, thanks to them, looked at the results very closely. Punctuation, capitalization, normalization of abbreviation, I would argue as well, are domain specific. And as a result, this means that no dataset that is trained on editorial level of transcription for medieval times, at least, should be compatible between each other. A solution is then to keep an approach that stays simple and leave some work for the researchers. And we can see how to address domain per domain what we can do to certainly automatize the translation. And that's where we come to CATMuS Medieval. So CATMuS, I'm not going to go back to the full story, but it started with Crema. So if you want to look at the paper from Ariane Pinch, sorry, whose name was here, sorry, no, her name is at the end, it's okay. We started to work on the guidelines that created the whole thing. We started that in 2000, I don't remember. But basically, the choice that we made is we don't do graphic distinction. We don't take care of ligatures, and any emphasis on the letter, regardless of its form, is transcribed as capital letters, including if the emphasis is only conveyed by the size of the letter. I was told, so I am not a paleograph. I was told that basically capitals don't really exist in medieval manuscripts, or it's a complex concept. And so basically if a letter is bigger, let's transcribe it as a capital. And then the various signs fall into 2 main categories. You have a large number of that are addition to base letter with as diacritical mark, such as macrons, or superscript letter, Q superscript I for qui, and their meaning is often context dependent. Diacritics are treated as separate character using the Unicode decomposed form. In Unicode, you have 4 different forms. The ones that you use when you, English people would not know that because I was speaking about accent, but you don't have accent in English. French people, when they type things with accents, they type in NFKC, most of the time. So it's canonical version of the characters, and C for compose. So the E and the accents only form one letter. In NFD, you have the E followed by the accent. And so it's two characters. And if you use backspace, you will remove the accents before removing the E, which means that the models learns those signs differently. It's not E plus E accentuated E, it's E and accent that the model is going to learn. Few are separate semantical signs, such as the et for et or a, or letter with strike-through marks, such as p stricken through, which in Latin most of the time stands for per or par. For these, we resorted to medieval Unicode font initiative, which for most of their characters are Unicode valid. And there are 5 full minutes. I'm not going to go into the punctuation details. So this was a situation when we published CATMuS, all the other large data sets that we could see for computer vision and HDR with different tasks. And basically the biggest data set was Oriflammes, which had book and documentary scribes and resolved abbreviation, didn't take care of character variation, and did modernization. When we published CATMuS, it was larger in terms of languages. I think the first version of CATMuS has 9 languages. Larger in time span, sorry, and larger in number of lines. And the output of that is when we train on a new language, when someone comes with a new language, adapting to this new language is fairly easy. We need a few pages, which basically helps the model knowing that a W is possible in this manuscript, or a K, because those are fairly rare later in Italian manuscripts or Spanish manuscripts. And this is the kind of distribution that we have. So the dataset is not perfect. It has huge biases towards French, Latin, and Spanish. And it has a huge bias towards the 14th century, as you can see here, and the 15th century, as you can see here, or towards specific scripts, such as the Textualis, which you can see here, which is basically the script from the 14th century. We have one language which is nearly represented in all scripts, which is Latin, which is obviously the only language that was written during the whole period. There were another bias I wanted to talk about, but let's go forward. The result of this, of training this generic model and having things that are compatible between different languages, which still needs you to resolve abbreviation if you want to edit the text after, is that we have a team of maybe 20, 30 people of research scholars, and not even counting transcribers, because we will be more like 50 or 60 people. But the people that are basically hiring or doing the research or trying to find the fundings, the work we have done together led to a situation where we have made this test very recently. We take the generic model, which is a little bigger than the number of manuscripts I've shown you just before. And we trained on 20 manuscripts individually for 10 epochs. So it saw all the data for each manuscript, and each manuscript has at tops 5 pages. And we took 50% of that line for training and 50% of the line for testing. So that's a very hard kind of situation. And each model was trained under 10 minutes on this very laptop, which is a Ryzen 5 laptop. It's not GPU, it's just a CPU, it's just recent. And we went to up to 30% of CR reduction with as low as 100 lines. So the situation is not perfect for everything. You see that some Latin manuscripts are harder than some Venetian manuscripts, for example. But always you can see that after the model, it's reduced, except for this very model, which I should have upgraded the graph, but didn't. where we found out that all our lines were shifted by one. So obviously the model couldn't learn and couldn't improve with bad data. I think it's my conclusion slide. I want to talk about something that I started as more or less a joke in a discussion with a colleague, to say that CATMuS might be seen as an ecological choice. And I'm going to try to argue that, probably badly, but I'm going to try. In CATMuS, AI hallucinations are limited, and we have more misreading in models than hallucination in the sense of ChatGPT or in the sense of Parenti earlier. Yet, some historians, and it's not that I have a beef with historians, it's just like most people that want to do editorial transcriptions are historians, from my experience. And researchers in medieval literature still prefer to train a specific, rather than generic, model for a text, a genre, or a manuscript, where abbreviations are resolved. The model has the limitation we have seen, and it won't be reusable, the data that they are trained, they produced, until technology fixes it. So basically, because the model only see one line at a time, the issues that we have of context won't be resolved until we find a model that is able to take all the line into context sequentially, so that the abbreviation can be resolved correctly. There will still be the other issue about each field having their own approach to resolving abbreviation, but at least the context issue will be resolved. So we can see a world where this might work in 10 years, that their data might be better. The issue, even if the technology fixes the context issue, is that the hallucinations are hidden and the errors are hidden. We don't know when an abbreviation was resolved. We can't know when or if it was badly resolved, if it was an HTR error, or if it's an hallucination. And unless we see the manuscripts, we don't know that it's there, which is the worst thing. A bad transcription in CATMuS, you can see directly that it's a bad transcription. A bad abbreviation resolution, it's much harder. By doing so, their data is partially compatible with other datasets, and I will argue that this vision is short-term win and long-term cost. It works very efficiently if you work on one manuscript and you have to fix the little quirks that you find out. But on the long term, we don't know if this data will be reusable. On the other hand, CATMuS by designs limits hallucination and keeps the manuscript text quite close. Not perfectly close, because we're still a translation to some extent. On the short term, it's way more costly for projects to run CATMuS approaches, as not only they need to type the transcription with the abbreviation, but after they need to resolve the abbreviation by hand. However, abbreviation resolution is a task very close to other tasks in NLP, such as lemmatization. The technology is already there. What we are lacking is the data to support this technology. So basically what we need is more ground truth to resolve abbreviation and train model to resolve abbreviation, or even to normalize to some extent. And so here, I would say that it's long-term win, but short-term cost. Sorry. This is the link to the dataset, and I just want to remind you, oh, that's not the last version because I forgot the name, that CATMuS is a team project run mainly by Ian Pinch, Alix Chaguet, Simon Gabet, and myself. And I want to give a special shout out to one person. Even though CATMuS Medieval owes a lot to multiple people, our main data creator is a PhD student called Madame Atenia Vlachouev-Statu, who works at the IRHT and à l'École des Ponts, l'École des Mines, l'École des Ponts, one of those, who is always coming back to help us annotate the kind of script or the datation of the manuscript. Thank you. I'm gonna